Good morning and a very warm welcome to everyone to this masterclass on an interesting topic of Edge AI, brought to you by KTech Center of Excellence Data Science and AI, powered by NASCOM in association with Capgemini. My name is Supriya Samuel and I'll be your host for today. And I'm joined by my colleague Aditya, who will be a part of this masterclass today. So, as you all are aware, Masterclass aims at connecting the data science and AI community with industry leaders to learn and navigate through a wide range of topics in the space of data science and AI. In this edition of Masterclass, we have a pleasure to have Bikash Dash from Capgemini, who will share his valuable insights on data science consideration for building AI ML models, which can be easily deployed and scaled on edge. Before I hand it over to Bikash, a very quick introduction about him. Bikash has over 14 years of experience in leveraging data science techniques to solve real-world business problems across domains and functions for multiple customers globally. His capabilities include solution architecture, ML ops design architecture, and CI/CD integration, global delivery, client management, product development, business planning, strategy, and team building. He's highly experienced in insurance, aerospace, BFS, gaming, and hospitality, manufacturing, and is SAFE 5 certified architect and a Capgemini senior certified architect. I urge you all to make use of this opportunity and feel free to queue in your questions in the Q&A window, which will be taken up by Bikash at the end of the session. Also, we will be dropping a survey link to get your feedback on this masterclass. So wow, I'm looking for this cracker of a session today. Without any further ado, I would now like to invite Bikash to kick off today's masterclass. Over to you, Bikash.
Thank you, Supriya, for the introduction and welcome all. I will just share the screen. Let me know if you are able to view the same.
Yes, Bikash, we can.
Yep. Okay, great. Hope my screen and voice is clear and we can get started. So I think well covered, Supriya. I have covered most, but just to add a thing that, okay, a few of my previous organizations with the likes of Boeing, Cognizant, and Mu Sigma, and definitely my hobbies on numismatics and notably. So I'm avid numismatics and things, but over and above, a typical data scientist and data science enthusiast, still learning and a lot of new learnings to come our way. So Edge AI, what we will cover today primarily would be in the space of what is Edge AI and why does it matter? Everybody is speaking Edge AI, but where is the edge actually? You should be able to identify and define, right? It can be, for somebody, it can be the extreme end corner, or the tipping point can be the edge, or somebody who is at least 1 feet away from the edge calls it as an edge. So how do you define the edge first, and what is the edge? We'll also see that how people are thinking that, okay, is cloud AI moving towards Edge AI, or is it the end of cloud AI that will make Edge AI more implement? Then the main perspective of Edge AI enablement, the training and inferencing aspects, that is from the data science aspects that we will touch upon. I will touch upon few of the enabling techniques that will help you deploying your models or at least training your models. Definitely each of those models can be a master class, but at least I'll give you those food for thoughts or food for points that you can go and explore and see that, okay, how do I enable that? And finally, some of the explorations on the applications, which I know most of you may be consciously or unconsciously aware, but let's see how that is. And then the future. So we are already into 8th or 9th year after the evolution of analytics, to BI to analytics to data science today. Still, we are looking for future. So let's see how the Edge AI feature looks like. So before I start, I thought to make the mood a little light and see. So edge computing has been there from ages. It is not that we are just coming up now. Okay. So I will touch upon this very example. So remember your childhood days when you were fighting with your friend. So what is the resolution? How would you resolve the fight between yourself. So you will have some ideas, some thoughts, but how would you resolve? If you go to your parents or their parents to get the fight resolved, you are taking your data points, everything to somebody else at some other place and then resolving it. So that is cloud AI. If you are involving another friend or your friend gets involved and is trying to help you out, resolve, make the friendship back, that is where you are trying to do something in the nearby or taking the nearby ecosystem infrastructure to help take your help. That is your fog AI or near edge AI. Over a period of time, you develop your intellect, you have more understanding, you have more mindset. So you try to find ways to patch up. You resolve your problems then and there. That is what is edge AI. I try to create this and relate to a very typical real life human problem and how we have evolved from taking our problems to parents to friends to resolving it ourselves. The same way, a problem which happens at some site, how do we go and inference it from a cloud to a near edge to on the device is the basic practicality of understanding edge AI. I hope that creates the initial thought process of how you want to take edge AI. Now, what is edge AI and what is why does it matter? Definitely, the edge AI is a two large components. One is the edge computing, definitely the infrastructure aspects of it. And second is the AI aspects of it. Both have to amalgamate in a real world scenario to and have to balance out. You cannot increase the infrastructure on the edge. You cannot reduce the capabilities of AI at the edge. So how to create those balance and things and what are the driving forces on that? That is more important. And if you see this impact radar of Gartner, you would see that uh, the only thing that is there in the productivity resolution with the immediate impact and effect is nothing but edge AI. So that's how important and how relevant it is in the current day scenario. And the driving forces, if I may ask, may tell that maturation of neural networks, we have gone from AI to, but today with the DNNs, the distributed neural networks, we can really generalize the machine learning, train and deploy AI models on the production on the edge. Then coming to the compute infrastructure, we have tried to grow from the Param computers, which used to be a room size from 1980s to as small as a chip. And with the GPUs and other things coming into the play, things are really easier for deploying large scale models in a smaller size, right? And definitely IoT adoption, the widespread IoT adoption, anywhere you're going, you're wearing your wearables, vehicles, everywhere the data is getting generated. But data generation is not the point unless it is processed and processed with right time and visibility. Pushing it to the cloud, getting the inference may be a delayed, may lose the essence of the criticality. So hence it has to be processed on the edge. And definitely the level of innovation, right? So with Google classes and all, you can innovate, identify. So a lot of plethora of opportunities have flown in to enable health monitoring. A lot of things I will touch upon, right? Moving ahead, just to touch upon that, the worldwide total in 2020, there, if you see, we generated 47 gigabytes of data, which is very small, what we expect to generate in next 1 decade. But that is not the point. The point is how much of this data are we actually processing it and how much of the data are we actually storing it, right? The gap is too high because the cost of transporting this data, which is getting generated on this device to the cloud and then processing it, is too high. That's why if you process this data, secure this data, even privacy restrictions on the edge, the new challenges will turn into opportunities of how to process this gap, or the edge AI will be enabled, right? Is edge AI hype? Not at all. So if you look at both the hardware and the software markets on the AI aspects, why hardware and software, I have divided it. The reason being edge computing, that is the hardware, AI, that is the software aspects. You can see the growth over the next 5 years from 2022 to 2027. And definitely the CAGR for both are plus 20% year on year. There are definitive components and driving factors where IoTs or the COVID transformation, where we are looking into the life with a different perspective, are there. And definitely Asia Pacific is the growing market, not only because it is a unsaturated market, but it is also due to the intellect and the people who are there who can feed into those edge AI kind of a solutions. Now, coming to the difference between edge AI and cloud AI, right? So I think I have fairly described it, but there is a definitive trade-off when you are doing a edge AI to cloud AI and cloud AI to edge AI, because you are moving to the edge to do something on a real time. So you are gaining the time quotient of it, right? But at the same time, you are falling short on the cost, you are falling short on the infrastructure, the energy consumption. So how do we enable and create a balance between that? Because it cannot be that, okay, I just need the thing. In this world of sustainability, everyone speaking of AI sustainability or sustainability for AI, energy conservations, we have to have a trade-off. When it comes to energy consumption, definitely there are things like TinyML and all, which are very beautifully crafted and enabled so that you can transform your large scale ML models into the compressed ML formats and deploy it in the edge, right? So that's how that connectivity issues. We always face connectivity issues, at least in, I think with the passing of COVID and people working from home, the connectivity reliability has gone up, but still we are. So just imagine that on a driverless car, if today Tesla wanted that, okay, you have to be connected to the cloud through and through for your car to be auto drive mode, nobody will buy that car. The only thing is that they have the confidence of the data and decisioning getting done on the edge, that is on the car itself, without even the connectivity to the cloud. That's where they are able to do that. So the connectivity issues there. Processing ability, that has to be trade off. I cannot just go and give everyone a large hard disk to be attached to every phone so that you can process your large scale images which you're taking from the phone. Or I cannot attach a hard disk to every CCTV camera to process it. How do we do that trade off and what to manage and do? Latency is, of course, an well known factor, which is again augmented with the connectivity issues. And finally, the security aspect. So security is something, is a very typical topic across the Europe and things, so GDPR, and now India is also taking it quite seriously. So Edge answers most of this question. If I tell that I'll process your data and give you the output, take my service on the edge, I'll not take your data, everybody will be happy. Today we are really scared even to install an app. We think twice, we take the feedback, somebody will be using our data. But when the security and things are on the edge, definitely it becomes more relevant and useful. Moving ahead, the key drivers behind the edge AI. I think edge AI, the data generated on the network, as I mentioned, is not fully unlocked, right? Different issues, security, latency, travel, and bandwidth. But even Gartner mentions that a portion of it or most of it, be it the IoT projects or even the mobiles or the things, 90% of the enterprises will be leveraging edge AI to process that data and generate the benefits, right? So many times the benefit is the end user, but they are not ready to give the data to us. How to ensure that benefit is enabled with the sense of security, right? Uh, Edge computing with richer data and applications, definitely the when the AI was booming, and there are four major aspects of any deep learning or things, like you have the algorithm, hardware, data, and application. Algorithm and hardware, we have solved it. Okay, we have the cloud, we have the strong GPT-3 and large algorithms which are there and are enabling. But data and applications are the key things. You have to define an application which can accept the data and process it within that. That is the answer given by the edge AI. And of course, AI democratization. So the question today is how we can make AI available to everyone. how to take it to closer to a person who even doesn't understand AI but can take the benefit of AI. So that democratization or the ubiquitous of AI can be enabled through the edge AI components. But today we stand at a different layers of edge AI. It is not as simple that, okay, cloud is there and data comes and we process it. Training and inferencing of the data or the models or the DNN models which are there happens at multiple layers. If you see the bottommost layer, that is the cloud intelligence, which are the training and inferencing happens in, that's the plain simple. You capture the data, push it to the cloud, that is done. But there are multiple layers as we start integrating the cloud to edge and edge to device, right? So the cloud to edge or the cloud training, which is primarily there, uh, you build the model at the cloud, inference in the edge, or you do partially on the cloud and partially you train on the edge. So all those combinations are there from level 1 to level 3. Primarily, if you ask me, in today's world, all our edge AI applications, inferencing, training, everything lies within the level 1 to level 3, right? The future scope lies from level 4 to level 6. That's where probably I will tell. So where we are trying to tell that, okay, cloud edge containerization, that training and inferencing of the model both happens on the edge, and cloud in a cooperation manner. Okay, partially it is trained and rest of the training happens there. Level 5, that okay, all in the edge, which is a far-fetched idea. That okay, I will say the model also is built there, deployed there, trained, and they're able to do it. But we will lose some of the overall generic model generations and things like that. But yes, that is a vision. And finally, on device. So today, if somebody tells boss, you can take the on your phone, you can train the model and things, yeah, I'll be very happy. But I need that much capacity on the phone, that much, at least my phone should not be heated. All those aspects has to be taken care, but we are moving towards it. So if you ask me, we are operating all our models, applications based on whether it is a vision model, whether it is NLP model, whether it is a simple ML forecasting or training model, we operate from level 1 to level 3, right? So again, based on the privacy and other concerns, you will move between levels to take it further. Let's get into the aspects of how we want the edge AI model training approaches to be there and things to be there. So if I tell you, there are 3 components when you are trying to define that, okay, I have to build a edge AI model training approach. I have to define my architecture. I have to define my KPIs, that, okay, these are the things that will define whether my model is working fine and is deployable and all. And I should be aware that, okay, if I'm falling short in one of those KPIs, which are my enabling techniques that I should do? Okay, this I should use for my model compression. This I should use for reducing the latency. This I should use for getting better convergence in my model, things like that. So we will touch all these things. So once you are enabled with all these 3 things and you are building models, so I'm not here to tell you about data science. Data science, all of you know well. It is how to enable your model on the edge. So again, you have to define the architecture. So centralized is the plain vanilla architecture where you are having the cloud. You get all the data from different devices and you are able to centrally train the model and then push it for deployment again onto this thing. The second one is the decentralized, where you have your individual weightages and the computing modes, trains that in the local data and local, and you preserve the privacy as well with that. Finally is the hybrid mode. That is the current way, and I think the federated learning fits more into this hybrid mode where you do the training and things at the individual level and then come back at a central node and try to aggregate the model weights, create a generic model, and then give the best model in the class across the nodes so that they can leverage from the other learning without typically sharing the data. So these are the typical 3 types of architecture where you can enable your edge AI as a model. to be trained. I'm speaking on train. I'll come to the inferencing at a later point in time. So, but the next part, which is the KPIs, is very key, right? So when training approach is taking, 6 key performance indicators are very important. Definitely the training loss, because when you are training it without the actual data, or the data is segregated, definitely there will be some training data less. And so you have to, this is optimization problem, and you have to minimize the training loss, right? The second piece comes as convergence. Definitely decentralized model, decentralized approaches are the need of the hour, considering the data travel, uh, data migration costs or the privacy issues and all. But under the training mode, the convergence value will depend on how synchronized and updated your model, how regularly you update it. So the more integrated or more easily you are able to synchronize your data and retrain the model, the more the better the convergence will be. If 3 devices are separate, no convergence, then the typical architecture also fails. So that's where privacy, definitely it's a no-brainer. If the data lies in the edge, definitely the privacy quotient is there, but it cannot be every time, right? So you cannot have all the data processed on the edge. Sometimes you have to get some of the unmasked data, or some of the masked data, to get the trained on the edge, on the cloud, to ensure that you have a better, stronger, accurate model into it. Communication cost, yes, you cannot have latency, but at the same time, the number of transaction you make, you send the data, receive the results, send the results, receive the model. So it keeps on adding to your, and definitely communication is an indirect impact into the sustainability aspects also. So that has to be taken with the real care, that how many number of calls you're making, how many number of communications you're making. Latency, definitely we are in a world of instant, where even we are expecting the groceries to be delivered in 10 minutes. So definitely with a click of a button, with 5G already enabled, all of your houses getting wired with at least 100 Mbps speed, you don't expect that something will take time to buffer, something will take time to process. And when you are being marketed for a edge AI kind of a thing, you expect that, boss, it is on my phone, why it will take so much of time? So the training, and especially when it is training in the aspect of it, definitely that expectation has to be set, where latency is a key things. And when you are doing it on the edge nodes, definitely this capability puts a more tight dependency attached to it. And energy efficiency, from the prospects of sustainability, the number of communication, number of times you upload the data, you communicate to cloud, or number of times you retrain your models on the things, definitely there would be challenges, there would be issues, right? So energy efficiency from sustainability. So when we see this key for 5 or rather 6 KPIs, which are very much needed for calling your edge AI model training to be a success, there are different enabling technologies as well, which which will be helpful. Federated learning, um, this is one of the top. There are multiple frameworks today, and multiple organizations like an NVIDIA, Azure, all the clouds are enabling the federated learning. And federated learning is a very easy and way of ensuring privacy, at the same time getting good, and it is a hybrid architecture, as I mentioned. Then you have the aggregation frequency control kind of approaches, where deep learning model in the edge computing world is commonly is trained to be done in a distributed way and then aggregated centrally. You can tell that it is again a federated way or federated approach, but aggregation only of the model weights is done as a centrally, but model training happens at the edges. Gradient compression, again, gradient compression has got 2 very specific components. The first being the gradient quantization, which is actually the compression of your gradient factors to ensure that your model is not very heavy, does not need a lot of vectors and input fab parameters to be enabled. And then the gradient sparsification, which effectively helps you the communication cost. So it reduces the communication overheads that are needed to ensure that you are enabled. There are other techniques like DNN splitting, even knowledge transfer learning, which is more of transferring the inferences for the secondary retraining of the models. Gossip training, it is as simple as passing on the gossip from one node to the other node, where the inferences from one node to the other node. It is more of a new decentralized method where randomized gossip algorithms integrate together and try to develop and deliver, right? So this is what is overall the training approaches. I would put it in a nutshell for you to consider while you are trying to embark on a journey to build a edge AI training framework kind of a thing. Now let's go to the easier part of it. The easier part of inferencing. Everybody is using the inference edge AI models in the inference, be it your smartwatch, be it your mobile phones, driverless cars, even nowadays the laptops and things are having most of the activities done in the near edge kind of a scenarios, right? So this we are exposed to the inferencing part quite a lot, and I'll touch upon few examples also while I take you through this architecture. So if you see the first that the edge-based architecture, which I have just for demarcation, I have mentioned it as device A, B, C, D. So device A, where we have the device and it is connected to edge server. So the edge is so here edge doesn't mean the endpoint. Endpoint is the device. So device AI is still a farfetch. So where I mentioned, okay, you are connected to, for example, to your router or something, that is your edge, and you have your device as a mobile phone or things, right? So that is kind of a thing. That is primarily the edge-based mode. Then the device-based mode is where you perform the model inferencing in the device, right? So the first one was mobile phone just sends the data to the nearest edge server and inferencing happens and you quickly get it. But the other one is where you are connected to the edge server, but you do the inferencing on your device, and the results may be transferred when you are connected back to the edge server on time or things, just for the future this thing, right? And then there is a edge device mode, right? So in which you do a partition kind of a thing. Some quick aspect of the models get processed on your device, and rest of the data is passed to the edge. And rest of the inferencing happens on the edge, and the results are updated for you to look at a later point of time. So the major heavyweight, if it is needed, is done at the edge level. The basic quick things that are needed are done. For example, I would say you are uploading your documents and validation or things. So the fingerprint validation immediately happened, and the rest of the documents was uploaded to the cloud or the server for a later point validation, and then the results were updated, something of that sort. And then the edge cloud combination, where a cloud is also involved. I think the previous example was more of an edge cloud kind of a thing, where the fingerprint reader is the edge, the documents get are done on the cloud, and whether you are liveliness detection, where you are moving your eyelids to check whether the person is live or you're just showing a photograph, that is on the device. That okay, that is that. So all three components, where you have the liveliness check, that model runs on the device. Then you have the fingerprint reader, which happens in the local nearby server, that okay, it quickly tells that okay, is the same person. And then you upload the documents, which gets processed for the validity and things that is happening in the cloud. So this is how example, I hope everybody can relate it. If you go for any mobile phone or any of the SIM cards kind of a thing, this kind of validation is quite common nowadays. So I think this example will help you to resonate these things. So if I talk about the key performance indicators, they are not a lot different from what we spoke in the training aspect, though their priorities and their objectives would be different when we are doing inferencing versus training, because training is more of creation, but inference is more of making the decision. So that's where accuracy, latency are much more prioritized and more important when we speak of uh, uh, so I'll focus on maybe the two new KPIs, which is the communication overhead and the memory footprint. So communication overhead, definitely what happens when you make so many communication back and forth, you have to have the communication IDs and things so that you can map it, and later every transaction creates an overhead. So we should minimize the transaction of that, and the performance and things will get further hampered if the number of movements is too high. So that's where the communication overhead affects the inference performance over a period of time. And memory footprint. What is memory footprint? Uh, Memory footprint is wherever you are storing the data, it will start having footprints, right? It has to be tracked because of privacy and other concerns. And optimization of this memory footprints is a non-negotiable thing. So where how many times you are storing the data is also very important. And redundancy of the data. If you're storing on the edge and again in the server, there is no point. If the inferences are done at the both sides, there is no point. So inferencing, generating the output and saving them at different points definitely has to be optimized so that you have a better memory footprint. The enabling technologies are totally different for inferencing versus training, because training, as I said, it is more of a model creation, model generation, which can run train in different format. But inferencing, we have a lot of things, and it all depends on which KPI you want to optimize and how quickly and how readily you want to get your information back on, right? So definitely model compression is one aspect of it, where we enable a compressed model on the local and have a more on-device kind of a scenarios, and the main model is running, the all capability model is running in the edge or the things. We do model partitioning, where part of the model executes here. And definitely model partitioning answers quite a lot of KPI challenges that we may have, be it latency, energy, or even privacy. So you partition the models, the model components which need privacy information to be processed is processed on the device or edge, whereas the ones which do not need PII information to be processed can be passed on to the cloud. So you partition the models accordingly, right? Uh, there is something called as a model early exit. So you know that within a deep neural networks, or the distributed neural networks as we call it today, there are multiple nodes and multiple layers. So many a times you don't execute all the layers to get the data out. So you tell, okay, I'm fine with the first 3 layers of execution and let me get the inference and help it, and later on I will process the data. So you do a quick model early exit. A model early exit is a very good response for the latency issues. The applications which have latency issues leverage this kind of things. Edge caching, you cache some of the inferences at the edge, and you keep on caching till a definitive amount of data is generated for you to run the larger model, right? So edge caching is a very old technique. Even our internet, we have the cache so that we don't load the data again and again, or the inferences again and again. Input filtering. Input filtering is a very important thing, where you want to reduce the load on your edge devices. You should filter your data, and even it is very much important for any device, I would say, even for moving the data from on-prem to the cloud. For example, you are using your vision AI on the cameras to process whether a person is wearing mask or not. A very common use case. I think most of the people in colleges and things have done this as a project. But to make you understand that every frame for becoming live, or a live video, every second has got 35 frames. So if you see, there are 35 frames, and if you process 35 images for a given second, for processing 60 images, you are processing more than 2000 images. Think the amount of pressure and load you'll be putting on the processing algorithm. And you mind it, you cannot process in zero 0.3 seconds a image, at least in a non-GPU environment. So you should first have an input filter which will identify that, okay, I will pick up every 8th frame or 10th frame, and classify that and only process when there is an event detected, that okay, we process it for the further details only when event. That is what is input filtering. Model selections are there. Then multi-tenancy, you optimize your things for multiple applications and multiple algorithms. So when it is not being used for other application, you can cross leverage those kind of things. And then there are application specific optimizations where people are ready for going ahead with communication overhead or energy, but they cannot compromise on the latency. They're fine with high energy consumption. So again, it depends on which type of application specific optimization you can do, and based on that we can identify under. But these enabling technologies are not one technology cannot help you optimize all of them. So you have to prioritize which are the KPIs you have to enable. Based on that, you have to choose that architecture. Based on that architecture, you have to select the enabling technique and employ. So it is typically a big filling the elephant in the room, where everyone wants some part of, touches some part of it and prioritize that and has to describe it in that way. But there is a different technique and approach for each of those approaches, right? So moving ahead, typically I wanted to touch upon this edge AI helping the security aspects of it, because this has been a perennial problem where we haven't been able to get data from our client. We haven't been able to. So we should educate even our clients and things, and adopt the edge AI approach. And edge AI doesn't mean that everything has to be on the edge. There are multiple combinations, as I touched upon the previous slides, like creating the cigar. So there are different aspects of privacy enablement which edge AI brings onto the table and will help us taking it further in the journey of AI adoption and AI democratization. Most of the things are now already adopted. Our security systems are much more advanced, but still the other side of the world, the hackers, the crackers are already on the job to do a better job. But how do we enable edge AI? They are helping us with managing vulnerabilities, creating patches cycle. So all these patches and things can be edge trained, right? So if there is a breach and there are things, you can train your model to run over and create those patches, so that if there are cyclic attacks or a periodic or frequency based attacks, they are overcome. Early threat detections are there, securing applications are there. So all those things has to be enabled, and edge AI makes it more easier for you because you are not transferring the data it on a regular basis. So enabling this kind of security measures definitely creates a much better environment. Uh, whether it is AI for edge or edge for AI, sustainability for AI or AI for sustainability, those questions keep on popping up. So definitely AI is enabling edge computing. So the infrastructure optimization and everyone are using AI for optimizing those aspects. At the same time, enabling the AI on the edge infrastructure is delivering more to the end users, be it on the application, privacy, security management, communications, and there are lots and lots of use cases and things that can be there. So how and where to implement? Yes, there are multiple scenarios. Just for touch purpose, let me take communication. So if we enable the AI aspects while optimizing our things and try to see, we will have faster model convergence, but at the same time we will have personalization and intelligence and more autonomy on what we are trying to communicate, right? So that's where we think. But we should not only think that AI is getting implemented on the edge, but AI is also enabling the edge to bring up the potential for this aspect. These are some of the sector specific based applications which are I'm trying to portray. So AI in retail, you would have seen that, okay, the carts are fitted with scanners. As you keep on dropping your items or groceries, it keeps on, and the self checkout system is there. You just reach to the checkout center, the cart itself will tell, okay, this is your bill amount, and you check out, kind of a things. Smart counting, flow managements, we worked for one of the largest network rail companies in UK, where we wanted to optimize the passenger flow into the different sections of the platform, because everybody wants to go to the front end of the train without understanding the back of the train also will have space, but they want to get into the front of the train so that they can get down quickly and take the escalator. But how to optimize that thing? So doing it on real time for a station manager. But if I capture the image, send it to the cloud, get it processed, by then the flow would have already gone even within 5 to 8 seconds, right? So how to do those kind of things? AI in security, I think that's a real thing that is already implementing, and a lot of people are taking quite a large amount of benefit, I would say, at this point. And we should all think about enabling that aspects of it, uh, be it fall recognition, intrusion alerts, break-in, mostly video based, uh, but and even and transaction based. So, but yes, and they are getting enabled in that. AI in smart cities, as I mentioned, sustainability, edge AI, all are convoluted and are interrelated. Are not convoluted, rather interrelated, delivering benefits in a more symbiotic relationship. So planning, even hospitals are taking up to change the path of the incoming patients based on which is the best way. Even stores are doing based on the products they are trying to do. So that's there. And AI in production definitely is the new, I would not say new, but much more needed. And as I mentioned, automation and productivity increase, edge AI is there with a lot of things like digital twins and all, where you are enabled with IoT and things. Those data cannot be every time pushed through, but the inferences are more important, but both on the floor and off the floor. So recycling or tracking. So definitely the edge AI systems are enabling this frameworks much more better and faster as we speak. So
Vikash, sorry to intervene. We
yeah,
have last 15 minutes left.
yeah, this is the last slide.
Okay, sure. Thank you.
Yeah. So what to expect from the future of edge AI? So when we were in AI, when we were in analytics, we were thinking how to do it, do AI and data science. Now we are in edge AI, and what should be the future? We should be aware, because we may be doing it for a 1 year or two, but it how to look it through a scalability and sustainability perspective. So edge management is going to become a focus. So like we have infrastructure management, with so many devices and things are coming into our way, edge AI is going to become a big role uh, in the IT sector as we move. Definitely, as I mentioned, IoT, AI, all this convergence will be much more fruitful, more beneficial as we move ahead. 5G has come our way. Definitely, the communication becomes more faster, more relevant, and we can transfer more data from edge to cloud, and those kind of combination scenarios or architectures where cloud edge, edge device edge kind of scenarios will be much more easier to be perceived. Definitely the virtual reality services, where we want the scenarios to be completed in milliseconds or maybe in microseconds, so that the edge devices can scan and create those scenarios. That will be more. We moved from DevOps, and now with machine learning and AI, we are in AI ops or ML ops. But with such a large scale movement and all the techniques and other things which I touched upon, we have to start tying it down into a standard framework and a culture which will be driven by edge ops. That will be the new operationalization, which will cover not only the data ops, DevOps, and ML ops, but everything together on a edge device or a edge cloud infrastructure will be called as a edge ops. And finally, the digital twins. Digital twins are not only for manufacturing and things, but over a period of time, it will touch everyone, and we even as per the Gartner's 2022 emerging technology, digital twin will be digital twinning the customers or the consumers primarily. So it is not far off that you will have a digital twin of Bikash or Supriya at that, and definitely operationalizing it with the support from edge AI and IoT will be very crucial along with 5G. So that's where the entire scenario is. So yeah, so that's all about I wanted to touch in a small masterclass. I understand each and every small topics that I touch can be a masterclass, but considering the time, I thought to give you the food for thought and touch upon this. I'm happy to present here and open for questions.
Thank you so much, Bikash. I mean, that was really valuable insights coming from your end on Edge AI. What is Edge AI and the relevant use cases? I'm sure our participants have lots to take away from today's masterclass. So, Bikash, I'll quickly, mention or there are like 5 questions which I see right now on the Q&A window. First one has come from Shrikant Pathi, and he's asking, can you show some use cases to understand the co-inferencing in different levels in these 6 levels?
Okay. Okay. So if I may, okay. So see, okay. So if I did not have a lot of time for use cases because that's there, but probably I'll take that as a feedback for next time. But if you ask me for the 6 levels, I will just touch upon quickly. So cloud edge co-inferencing. When we mention co-inferencing, suppose you have a model as I think I have touched those examples in different sectors. So cloud edge inferencing, the same Aadhaar card validation for a SIM card, for example, where you upload your documents and give a fingerprint thing. So your fingerprint validation happens on the edge, right? The edge device or the edge server, which is locally available thing. And your documents are uploaded onto the cloud for the validation against the different websites or the driving license portal and things. So that is cloud edge co-inferencing, right? Does that answer your question? Or I can share a few more examples as well.
Okay, thank you for that. The next question is from Dilip Singh. Will security be not considered a KPI for Edge AI, as there would be some data which will be present on the Edge device?
Yes, definitely. Security is the definitive factor for any edge implementation. No question. So data will be there on the edge, but it is fairly secured and less vulnerable, I would say, because it is not migrating onto the cloud. And edge devices are mostly within the internal networks or connected within a local area network or within the enterprise network, where it is not going out of the network. So that's why the security vulnerabilities are fairly less. But on top of it, there are other privacy enabling techniques also are employed while you are sending your data from device to the edge as well, for standard encryption or standard pseudonymization to ensure that data is secure even on the edge that you speak.
Okay, the next question is again from Dilip. Also, will some sort of monitoring of the performance of the Edge nodes functionality be considered important?
Absolutely. So when I was mentioning this performance indicators, especially in the inferencing part, these are the performance indicators, and this has to be monitored because an application just getting deployed for inferencing on the edge is not important, but its accuracy, its latency, and this has to be monitored. And when I mention it to be monitored, definitely the aspects of edge ops, where you are doing the monitoring, functionality, performance, all those activities at the edge level will be considered. And I think most of the applications are doing it and have a component of monitoring, logging as well at that. But again, it is an overhead over your own application and algorithm that is running. But how to optimize it and run, that is the part of edge ops that will be coming maybe in a year or two as a regular framework of implementation.
The next question is from Yashwant, and he's really liked this session because very insightful session. He says, can you speak a bit about how to approach reinforcement learning applications where on-device training is required?
Okay, so I think I touched upon it through knowledge transfer, but I moved quickly through it. But okay, so there are multiple approaches. Reinforcement learning is not just by taking the fallouts and feeding it back to train the model again. But again, as I mentioned, in the training aspects, you have different ways of knowledge transfer learnings. So these are the different frameworks which are already explored and validated to enable transfer learnings or reinforcement learnings on the edge enablement techniques, so that you can not only take the sample data but also the inferences to reinforce your and retrain your models, be it on the cloud edge enablement or edge device enablement as well.
Okay, the next question is from Lalkar, and he's asking, in a way, 5G is deterrent for edge AI. People would prefer to transfer the data than processing it locally. So he's asking if people would prefer to transfer the data than processing it locally.
No. I think that's a misconception that 5G will enable me to process. See, as I said, with 5G, why that thing comes into my mind, and let me build to a context to that. We are all feeling that, okay, we have paid those 449 pack and I have got 2 GB of data, or I have 100 GB Mbps of data, unlimited, I can upload the data. You may not be getting the cost, but somebody who is moving the data is getting the cost. So as I mentioned, the KPIs is just not performance. It is the latency. It is the communication cost, energy efficiency. So 5G may have come. I can transfer my data quickly onto the cloud, but there is a cost that is involved for processing on the cloud as well, and the connectivity, right? So my question to Lalkar would be that if I have a 5G connectivity to your driverless car, how confident and effective you are to drive that car? Because without 5G, your car would not work with the driverless mode. So that's where. So as I mentioned in the beginning, there are 5 to 6 different trade-offs. 5G is a good enabler, but not a real replacement of Edge AI. Edge AI has its own. 5G will be enabler. Edge AI also will enable 5G to deliver more innovative projects as we go forward.
So next question is from Anshuman, and he's asking where we could access the case studies related to the Edge AI.
Okay, so if you want few case studies, Supriya, I can share and you can pass it on. But again, if I may touch upon, everything which you are using is a Edge AI application. Today, you are using your phone to process the location, or you are trying to dunzo it one item to other. So it is processing only the location or the location tracking on the edge, but your time or the calculation, everything happens on the edge, right? Every data doesn't get transferred. So there are a lot of examples. I can share some of the case studies and the techniques that are there through you, Supriya. But enough and more examples are also on the net.
Sure, because that will really help. Sarvana Kumar Muthai is asking, how does it addresses the regulatory compliances like GDPR?
Absolutely. I would say I'm happy to have that question. So see, I touched upon few of the techniques like federated learning and cloud process, edge processing and all. So today, let me touch upon an example. One of my previous organizations, because they were in the defense and I was in India, I did not get the data to be processed from India. I had to travel to US to deploy the models because data cannot come here. So, but the GDPR compliant ensures that, for example, federated learning. I'll take the example because it is the most, I would say, prolific techniques today we have. And there are different techniques like PyShift, Flower, TensorFlow Lite, and all. So federated learning, what it does is we generate a standard model, send the model to be trained locally at your location, and only the model weights come back. Data remains with you. And when we get the models back onto our server from different units, we make a generic model or rebalance or normalize the weights and create a generic model which gets back deployed on the different nodes. The best example I would say is the 2D imagery of the scans, the MRI scans for during COVID, right? So we wanted to have automation so people can do it, but hospitals were not ready to share their data because of patient privacy and other regulatory, which is very strong even in India. So we sent the models to their individual systems. We deployed the servers at the individual hospitals where the data will not come out of the network, but our model gets trained there. Once the model is trained, the model weights and the model equation gets transferred into our cloud server where we normalize it and deploy back. In this, you get the two times of benefit. You are not transferring the data. Security and privacy of the data is maintained. Thirdly, a much better model, because the amount of data on which your model is trained is large. It is not that a hospital is confined to only the cases it has. It got the model which is trained on the data from multiple hospitals. So the privacy concerns answers lies in the edge AI, where inferencing, data transfer, all these aspects. That's why I touched upon specifically on one of the slides, I think the penultimate slide, where edge AI has a lot of answers in helping the securing the devices and the data that is getting transferred from the edge.
So I see a lot of questions here, and we are almost like, yeah, so we just have a minute left. So do you mind, extending this by
Sure,
another
sure.
5 minutes? Because there are a
Sure,
lot of
sure.
questions. So
Sure. I'm happy to. Not a
thank
problem
you
at
so
all.
much, Bikash. Really appreciate it. And participants will take up the questions which has come right now. And if you have any further questions, please feel free to pass it on to me and I shall share it with Bikash. So Surajit is asking how edge cloud is different from cloud system, as if the device is connected to an edge cloud, some kind of latency issue can be there.
Okay. See, again, latency issues are driven by multiple things. Mainly three things. One, what is the bandwidth and communication between the devices? Second, how much amount of data you are sending? What is the quantum of data? Third, what is the model processing capability? How effective and how good is your model that is processing? So when you mention edge cloud and cloud, see, again, edge cloud is nothing but having a cloud in your geography. It is something as simple as that, so that the distance of communication is reduced, right? So with all these aspects, you have to create a right balance of having the right model deployed. And as I touched upon different techniques, you can have a partition based model, you can have compressed models on the edge which processes partially, and then you process the rest of the data on the cloud. So those kind of techniques can help you delivering the right information or inference which are needed without any latency, and the other details which can wait for a batch level or a periodic processing.
We have another question from Prasad. We are entering 5G, but still we have not exploited 4G completely. In technological obsolescence, how can edge AI solutions keep updated in advancements?
Okay, so see, 5G, we have not, I rightly agree with Prasad. We have not completely explored the 5G. We are looking towards the vision of 6G. 4G we haven't explored, but again, it depends on the country to country and area to area, the infrastructure, and because 5G will take another, if not a year or two, but at least 3 to 5 years to be enabled, because the infrastructure and things are pretty costly. To your question that whether how technology advancements will happen with 5G versus edge AI, definitely there will be dependencies and bandwidth optimization and things has to be done. But I see 5G as more of an enabler rather than inhibitor. So when you have something running effectively on a 4G kind of a communication channel and network, 5G will help it to be better, if not otherwise, right? So we may not be able to right away tap the potential of 5G. We have to do further optimization and implementation, but definitely the things which are getting executed on a 4G environment and things can perform at least at the same performance level or better in 5G.
So there are two questions come from Anshul.
Mhm.
And the first one is, all the edge devices needs to send the data to cloud. This could depend on the connectivity. This could be one of the problems. And then models need to be trained ongoing basis using data from edge devices. This may raise, so he's asking if this may raise the cost of hardware and software at the local level. Models need to be trained on ongoing basis using data from edge devices. So will this raise the cost of hardware and software at the local level?
So see again, the first question which you had, edge devices need to share the data or send the data to the cloud on regular basis. That is the typical objective, that we don't send the data multiple times and process and do the inferencing at the local level to avoid that cost. The second piece, yes, ongoing basis, if you want to retrain or as I answered, the reinforcement learning and ongoing basis training and monitoring, yes, the inferences and performance has to be monitored. But again, there are different optimization techniques which will enable you to do it in the best way, better way, if not the best way. uh, Infrastructure and cost will definitely go up, because you are making a transaction, right? You are sending the data, but you have to trade off, as I started my discussion with, that edge AI is not all good and it is not all worse also, right? So there has to be a trade-off. You cannot do everything on the edge. Something you have to send it to cloud, and cloud is not enabled for everything, like latency and other things. So you have to depend something on the edge. So you have to balance it out, what you want to do and how you can optimize the cost. Definitely there will be cost increase if you want to train a model on an ongoing basis. For example, you want to just send a model and you forget it, that's different. But we need to monitor, and that will be a cost impact and info, and we have to optimize it through different enabling techniques.
So, Bikash, last question from Shyam Sundar. I'm not sure this is a valid question, he says, but then he's asking, metaverse adoption is low cost, VR headsets are still expensive. Similarly, will Edge AI remain in concept phase, since the devices will need to have more computing power and digital infrastructure setup cost will be high?
Okay, no, the question is valid. Thanks, Sundar. So see, metaverse is in the early phases of evolution, right? So it is in the same phase where the computers were in the 90s, right? Where if you wanted to buy a single pen drive in the early 2000s, it used to cost us some 2000, 2300, and now newspaper people are giving us as complimentary pen drives, right? So it is the same way. The evolution will happen, and the metaverse AR VR headsets will drop, and it will happen. Edge has gone up that plateau curve. And to be honest, if you go and see the Gartner hype cycles starting, Edge AI appeared first time in 2018 on the Gartner hype cycle with a horizon of 2 to 5 years. And mind it, even after 5 years, you go and see the hype cycle of 2022, you will find Edge AI still on the top of the plateau, right? That shows that the evaluation and opportunities that are available are growing, and people are innovating a lot more. Edge AI devices are more of computing and enabling techniques which are there. And since we are going into the chips and other things which are getting evolved, we are in much better and enabled state for Edge AI. Your phones are the very good examples of your Edge AI. When we started, Ericsson's and all were having a big phones, even but nowadays the phones with the compute capability and the applications that they can handle are way beyond, and they are your edge devices, right? They are your edge servers. Sometimes phones are also can be enabled as servers, right? So uh, edge, we are well above the curve, and it will not have any hindrances as per I see. Definitely the innovation challenges and the privacy challenges will be there, which you have to work it out and optimize. But metaverse will take time to reach the every foothold, the same way how phones took some time and a curve before reaching to every common man. So today every common man is holding a smartphone. Previously the vision was that every person should have a phone, right? The same way metaverse headsets and things will evolve. will get better approach enabled and better techniques enabled.
Thank you so much, Bikash. That was a great session, and I would like to thank all our participants also for taking out your time to attend today's masterclass. Please feel free to provide your feedback on today's masterclass. Suggestions are welcome in the kinds of with respect to the topics you would like us to cover for the upcoming masterclasses. Thanks again, Bikash, and
Thank you.
looking forward to our continued engagement. Hope to have
Absolutely.
you soon with us again.
Absolutely. Thank you, Supriya, and thank you everyone for joining. Thank you.
Thank you.